A few more questions on the Poisson distribution, on what qualifies as Poisson distribution. So Poisson distribution, we have seen the probability of x is equal to little x is equal to lambda x e minus lambda divided by x factorial, where lambda is the mean number of events, and Poisson distribution with lambda and p closely approximates the binomial distribution if n is large and p is small. So let's see what will qualify as a binomial as a Poisson distribution. So number of chocolate chips in a scoop of cookie dough. This is number of events in a volume, and these are all independent events. So this is Poisson distribution. But if we ask average weight of customers arriving at a store in a 10-minute period. Now, average weight is not a countable event. It has to be a countable event. So this is, if anything, it's a continuous distribution. So it's not a countable event, so it's definitely not a Poisson distribution. Third is number of deaths from horse kicks in Prussia army in a year. Now this is a count, number of death, and it is a classic Poisson example. But whether it will be random and independent, then it will work. But this independent assumption can very easily be violated. So because the horse kicks may not be independent of each other, and there might be some times when there are more people dying from horse kicks than the other, and even if you randomly select a section, it is possible that there are other clusters of it, and it has to have the random and independent with the same theoretical rate across the plot, but that assumption is very easily violated. But it is the classical example of the Poisson distribution. So another question is, during a week, students enter a university center at an average rate of 20 per minute. What is the probability that a randomly selected 5-minute exactly 90 arrive? So you can say that, okay, we can do this as a Poisson distribution. You have 90 and 5, you can get a lambda, which is n times p. You already have the p here, so you can use this distribution here. We have everything. You have the mean number of events, and you have the x, which is 90, and you can do this. But the problem is that lambda is not going to be uniform. Students will not be arriving independent of each other. So this will not be a Poisson distribution, because students will be arriving in groups in a school rather than independent of each other. So and this will also be different varying upon the time. So this will not be a Poisson distribution. And number of fatal commercial airline crashes in a year. This will be a number of airline crashes in a year. That's a Poisson distribution. But number of fatalities in airline crashes in a year is not going to be a Poisson distribution, because this is not going to be independent events. uh, they will be, and they're not going to be, the lambda is not going to be same across the period of the year, so that is why this is not a Poisson distribution.